Welcome to this third-person RPG game demo built with the Unity engine. What we see first is the game's settings panel, featuring basic music and sound controls, with a vibrant cartoon-style background. Closing the settings, we return to the main menu. 3 buttons are displayed: Start, Setting, and Quit. After clicking Start, we enter the character customization system. Players can freely mix and match hairstyles, hats, capes, armor, weapons, shields, and face styles, all powered by a flexible prefab switching system. Fully equipped, we officially enter Level 1. The character spawns inside a dark underground cave, with glowing blue crystals lighting the way. The player runs across a wooden bridge and follows a glowing crystal stream. Notice how the scene uses emissive materials and point lights to create a mysterious underground atmosphere. Deeper into the cave, we reach an area scattered with giant bones and lit by flickering torches. The environmental storytelling hints at dangers that once lurked here. The player approaches a treasure chest. A yellow progress bar appears overhead, showcasing a distance-based UI interaction system. After opening it, a healing potion drops to the ground. Climbing the stone stairs, the player reaches a massive wooden gate. This marks the boundary between Level 1 and Level 2. Pushing open the heavy doors, we enter a grand dungeon hall with a red carpet. The first wave of enemies awaits inside. Here comes the real challenge. The player faces an ambush from a red giant, skeleton soldiers, and purple bat monsters. Notice the green health bars above their heads, always facing the camera thanks to a billboard script. The combat intensifies. The player swings their sword, but the enemies close in from all sides. Watch the player's health bar gradually shift from green to yellow, then to a dangerous red. Unfortunately, outnumbered and overwhelmed, the character's health drops to 0. The death animation plays, and the failure panel slides in with restart and quit options. The player chooses to restart and returns to the character customization screen. This time, they pick a brand new look, a brown leafy hairstyle, a purple cape, and different weapons, hoping for a better outcome. Back in Level 1, the player moves with more confidence this time. They quickly navigate the cave entrance and sprint across the wooden bridge, wasting no time on exploration. Racing through the crystal-lit corridors and mine tunnels, the player demonstrates the smooth camera follow system that keeps the action perfectly framed even during fast movement. Arriving at the skeleton area, the player skips the treasure chest entirely and engages the one-eyed slime directly. With precise timing and decisive strikes, the slime is defeated in seconds. Pushing through the gates, we arrive at a new area, an orc campsite with tents and bonfires. The player charges in and takes on the green orc guard with aggressive close-range combat. One by one, the enemies fall. The player's attack damage has increased through the leveling system, each kill granting 30 experience points that feed into automatic stat upgrades. As the last skeleton crumbles, the victory panel appears on screen. The full game loop is now complete: explore, fight, die, learn, and conquer. Now let's dive into the Unity editor. We begin with the animator state machine for the orc enemy. On the left, you can see the parameters: is move, attack, is idle, hurt, and dead. These booleans and triggers drive all the animation transitions you see in the center. Now we navigate to the project panel, opening the scripts folder under game. Here you can see all the custom C# scripts that power this game. Let's start with Skin Save Data, a static dictionary class that persists outfit selections across scenes. Next is the Boss Win Trigger script. This simple but essential component monitors the boss enemy's health. The moment the boss dies, it sets a flag and calls the victory panel show method, ensuring the win condition triggers exactly once. Now we're looking at the enemy controller, the core AI brain. It uses distance checks to switch between patrol, chase, and attack states. When the player enters the chase radius, the enemy locks on and pursues at run speed. Scrolling further down, we see the attack logic. A coroutine introduces a deliberate delay between the animation trigger and the actual damage check, so the hit lands exactly when the weapon visually connects. The overlap sphere detection ensures fair and accurate hit registration. Here is the enemy health script. It manages the dual-layer health bar system. The main bar drops instantly on damage, while the lag bar slowly catches up using lerp interpolation, creating that satisfying delayed drain effect. The script also handles damage flash, where the bar turns red momentarily on hit, and a shake effect that jiggles the health bar using random offsets. When health drops below 30%, the bar starts blinking with a sine wave alpha animation. Below that is the color gradient system. The health bar smoothly transitions from green at full health, to yellow at half, and finally to red when critically low. Combined with the enemy HP look at camera script, which simply copies the main camera's rotation every frame, the health bar always faces the player. Now we see the follow camera script. It implements smooth third-person tracking using lerp-based position smoothing. The right mouse button enables free look rotation with yaw and pitch controls, while angle clamping prevents the camera from flipping upside down. The game manager is the central coordinator. Implemented as a singleton, it counts all enemies at startup, tracks deaths, and triggers the victory panel when every enemy is eliminated. It also handles the pause system and the fail state when the player dies. Here is the player health UI script. Beyond managing hit points with the same dual bar system as enemies, it includes a full leveling system. Each kill grants experience, and when the threshold is reached, the player levels up with increased max health and attack power. The experience threshold scales by a multiplier of 1.5 each level, creating a natural difficulty curve. On level up, the player also receives a healing bonus of 50 hit points, rewarding aggressive play. Now we see the player spawner. This script instantiates the hero prefab at runtime, parents it to the correct transform, and immediately calls load and apply skin to restore the player's customized appearance from the selection screen. The premium player controller handles all player input and movement. It uses camera relative directional calculation, smooth acceleration and deceleration, and a custom raycast-based ground check that prevents the jittering common with Unity's built-in is-grounded property. The Skin Manager is a singleton that maintains lists of game objects for each customization slot: hair, hat, cape, armor, weapon, shield, and face. Switching skins simply deactivates all objects in a category and activates the selected index. Now we reach the Audio Manager, another singleton that survives scene transitions using Don't Destroy Unload. It creates two audio sources at runtime, one for looping background music and one for one-shot sound effects, with volume and mute states saved to player prefs. The character custom panel inherits from UI base and manages the selection screen we saw earlier. Each customization slot is defined as a serializable class with left and right arrow buttons that wrap the index and call Skin Manager's switch method. The UI base class is the foundation for all panels. It provides unified show and hide methods with deotween fade animations, staggered text transitions, and button hover effects including scale animations and a looping breathing pulse. The remaining UI scripts follow the same pattern. UI Fail Panel and UI Victory Panel override show and hide to manage cursor visibility. UI Setting Panel syncs toggle and slider states with the Audio Manager. Each one is clean, focused, and inherits shared behavior from UI Base. With the code analysis complete, let's pull the camera back and take a bird's-eye view of the entire game world in Unity's Scene View. You can see the level is composed of multiple floating blocks carefully pieced together in three-dimensional space. From the initial cave on the left, through the glowing crystal path, to the mine tunnel in the center, the layout forms a linear progression that guides the player forward naturally. Beyond the tunnel, the level branches into two paths. One leads to the red-carpeted dungeon hall, while the other connects to the orc campfire site. This modular scene construction streamlines iteration and opens up endless possibilities for future content expansion. That wraps up our complete game engineering breakdown.